Let's see question 29. We want to rationalize the denominator. Then simplify it if it's possible. And assume all the variables are positive numbers, so we don't have to worry about the signs. Let's recall our rational expressions, rational exponents for radical form expressions. If we have x raised by n, the power or the exponent is n, the index is m, so we can write this as x raised by n divided by m. So we have a fraction in the exponent. So the numerator of the fraction is the power of x. The denominator of the fraction exponent is the index. So when we rationalize, we want to rationalize this. So what does it mean? Let's see if this is in the denominator, right? It's in the denominator. What we want is we want this such n to be a multiple of m. Because if n is a multiple of m, let's see what happens. Let's say n, we can write as k times m divided by m. Then m divided by m, that becomes 1. So we just have x raised by k. K is some integer. So now it's rationalized. We don't have index. We don't have index anymore. So that's what we want to do. We want to somehow to make this n to be a multiple of m. So let's see the first question, A. So in this case, the index is 2. The exponent of the variable is 1, right? We can think as 7x as one thing, then the power is 1. So what do we want to do? We want to multiply, not equal to, I want to multiply square root of 7x. Why? Because in that case, well, I have to multiply 1. The 1 is the 7x over itself. Right? I multiply by 1. And 1 is a transformer. Anything divides itself. So in this case, the numerator is 1 times square root of 7x. So the numerator now we get a square root of 7x. But let's see the denominator. Denominator, we have square root of 7x times square root of 7x. Well, what's that? That's the square root of 7x divides square root of 7x being squared. Square root, because this is 2, right? 2 over 2 becomes 1. So the numerator is the square root of 7x, but denominator now is a 7x, right? So we have made n to be n plus n to be the same as m. In this case, we see the exponent is 2, the index is 2. So we want to match, at least match up with the index. Oh, that works for the single term in the denominator. It doesn't work for B, for C. So we're going to go back to B and C. Let's go to D. Right, D is similar. So D, for D, first we see the numerator has cubic root, denominator has cubic root. Maybe, let's see, should we put them together? Oh, no, we don't need to. Let's just multiply by 1 again. And this one is this. I want to make x term raised by 3, so I have to multiply by x squared. Well, this is also cubic root. I want to make a y raised by 3, so I have to multiply by y. Right, so I multiply by this. Then I have to multiply the same thing in the numerator, because in this, I can, with the expression, I can only multiply by 1. 1 is an expression divides itself. So by doing so, let's check the denominator first. I have a cubic root of x times x squared, that's x cubed. Y squared times y, that's y cubed. The numerator, or let's just write xy cubic root of, I have 2 here, I have x squared y. So 2x squared y. Now the denominator, let's check. We have x raised by 3, index 3. 3 over 3 becomes 1. Y raised by 3, index 3. 3 over 3, that becomes 1. So now just xy in the denominator. So in the numerator, we have xy cubic root of 2x squared y. Now, numerator xy as a factor, denominator xy as a factor, they cancel to be 1. 1 multiplied by anything will be anything. So we get the cubic root of 2x squared y. Okay, so now the denominator is 1. It's not a radical, in radical form anymore. Let's see E. Well, also have a cubic root. So we want to multiply under the same index. 9 is 3 squared, right? But we want a 3 cube. So we want to multiply by 3. 3 times 3 squared would be 3 cube, right? Then 3 cubes, cubic root becomes 3. X squared, we need x. Because x squared times x, that's x cubed, right? Then 3 over 3 becomes 1. So we need to do the same for the numerator. So now the numerator we have, I can write separately. I can write like this, separately. Okay. So numerator we multiply cubic root of 3x. Denominator we also multiply cubic root of 3x. Then the numerator have cubic root of 7 times cubic root of 3. That's 21. 21x. Now the denominator still under, let's see, all under the cubic root sign. Okay. So denominator now I have 9 is 3 squared times 3, I have 3 cubed. X squared times x, that's x cubed. Now those two, in the denominator I have xy now. Because x cubed, cubic root, right, 3 over 3 becomes 1. I mean 3. Same thing for x. X raised by 3 over 3, which is by 1. Why I read the y there? 3x, no y. So I get 3x. Now the denominator is rationalized. I don't have radical forms in the denominator. So the numerator doesn't have a cubic root of 21x. And that's it. Okay, so I have cubic root of 21x divided by 3x. So the only thing we care is the denominator have no more radical signs. Let's see, F. Oh, F is last one. After I finish F, I'm going to go back to B and C. Okay, let's see F. F, the index is 5. But the denominator will have x raised by 6. 6 is bigger than 5. So what do we need to do? Let's extend this. We want to multiply by 1. And this one, we want to make the power of x to be a multiple of 5. Let's make it 10. So we want to multiply by 1. And this one is x raised by 4 divided by x raised by 4. In this case, the numerator I have 5. The numerator I have 7, x raised by 4. Divided by denominator, I have x raised by 6 times x raised by 4. 6 plus 4, 10. So x raised by 10. 10 is a multiple of 5. So 10 divided by 5, that's 2. So the denominator will have x raised by 10 divided by 5, which is 2x squared. And the numerator will have 5th root. The index is 5. 7 times x to the 4 power 4. And that's it. So the denominator has no more radical form. Denominator is rationalized.